Imagine a day like any other. The sun climbs into the sky, people go about their business, the world feels solid and predictable beneath your feet. Then, a tremor. It is not the familiar short jolt of an earthquake, but something deeper, a long, low groan. The ground shudders continuously, a sickening vibration that makes buildings sway. Windows rattle, panic begins to set in, but this is only the beginning. The sky, once a brilliant blue, starts to shift in color, taking on a strange, sickly yellow hue, as gases, unseen but potent, begin to seep from cracks in the earth. It is a warning from a beast stirring in its sleep, a monster far older and more powerful than anything humanity has ever known. This is not a scene from a disaster film. This is the prelude to an event that has shaped our planet's history and holds the power to reshape its future in the most terrifying way imaginable. The shaking intensifies, roads crack open, rivers begin to boil as the heat from below rises, turning the landscape into a geothermal nightmare. People look to the horizon, not for an approaching storm, but for the source of this planetary agony. The air grows thick, heavy with the smell of sulfur, the planet's foul breath. What is happening is not a normal geological event. So, what exactly is this subterranean monster? What is a supervolcano? The term itself sounds like something from a comic book, but the reality is far more grounded and far more frightening. Geologists classify eruptions using the Volcanic Explosivity Index, or VEI, a scale from 0 to 8. A supereruption is the top of that scale, a VEI 8. This means it ejects more than 1,000 cubic kilometers of material. Unlike the classic cone-shaped volcanoes we see in pictures, a supervolcano is often hidden from view. It exists as a massive underground reservoir of molten rock, a magma chamber dozens of miles across. Over tens of thousands, even hundreds of thousands of years, this chamber slowly fills as heat and pressure build. It is a planetary-scale pressure cooker, and when the crust can no longer contain the force within, the result is an explosion of almost unimaginable violence. The ground doesn't just crack open, it collapses. The most visible feature is a caldera, a cauldron-like depression formed when the land falls into the emptied chamber. Some calderas are so enormous they can only be appreciated from space. You can drive across it, hike through its forests, and admire its geysers without realizing you are standing above one of the most powerful systems on the planet. This hidden nature is what makes supervolcanoes deceptive and deeply unnerving. The power of a supereruption is difficult to overstate. It is in a class all by itself. The energy released during a VEI 8 is thousands of times greater than the combined power of all the world's nuclear weapons. It can alter the course of life on Earth, triggering mass extinctions and changing the climate for a decade or more. When most people think of a volcano, they picture a majestic cone-shaped mountain spewing lava. Split screen, cone lava left, massive caldera erupting right. Think of the eruptions in Hawaii or Iceland. Rivers of molten rock that flow relatively gently across the landscape. These are dangerous locally, but their impact is typically regional. A supervolcano operates on a scale that is almost planetary. The primary difference is not just size, it's the type of eruption. Normal volcanoes might ooze or explode. Supervolcano magma is thick, sticky, silica-rich, and full of trapped gases. It acts like a cork in a champagne bottle. Pressure builds over millennia until the breaking point comes. Then a cataclysmic explosion vaporizes rock and sends a colossal ash and gas column into the stratosphere. Normal volcanoes build cones from layers of lava and ash. A supervolcano collapses the landscape into a vast caldera. After an eruption, it may look like a valley, lake, or plateau. The danger hides in plain sight, betrayed by geysers, hot springs, and subtle ground swelling. Think Yellowstone. Ultimately, the key difference is scope. A standard eruption is regional. A supereruption is global. The ash and sulfur dioxide can block sunlight and trigger a volcanic winter lasting years, worldwide crop failures, ecosystem collapse, and a challenge to human survival. History is written in the rocks beneath our feet, and it tells a story of past supereruptions, events that dwarf any natural disaster in recorded human history. These events are exceedingly rare, perhaps once every 100,000 years. Yet their fingerprints are all over the globe. One of the most studied is the Yellowstone hotspot, which has had at least 3 massive caldera-forming eruptions in its past. 2.1 million years ago, 1.3 million years ago, and the most recent about 640,000 years ago. Ash from these eruptions has been found as far away as California, Louisiana, and even the Gulf of Mexico. A continuous, deafening roar as a column of ash rises 30 kilometers into the sky, blotting out the sun. For hundreds of miles, the world would be buried, turning vibrant landscapes into gray, toxic deserts. The Toba event in Sumatra, around 74,000 years ago, unleashed nearly 3,000 cubic kilometers of material, possibly triggering a volcanic winter that lasted 6 to 10 years. Geologists trace thin layers of ash in sediment cores and ice cores from Greenland and Antarctica. Mass spectrometers and chemical signatures allow scientists to reconstruct size and global impact. These are not theoretical events. They have happened before. They have profoundly altered the course of life on this planet. The Earth's geological clock is always ticking, and these echoes from the past are a solemn warning for the future. An eruption from a supervolcano would not be a single fleeting event. Its consequences would unfold across the globe over months and years. A colossal cloud of ash and sulfur dioxide would be blasted into the stratosphere, high above the weather. Carried by high-altitude winds, this veil of aerosols would first cross the hemisphere and then wrap around the planet. The sun would dim, its light struggling to penetrate a thick, persistent haze. The sky would lose its familiar blue, replaced by perpetual gray twilight. Sulfur dioxide reacts with water vapor to form tiny sulfuric acid droplets, aerosols highly effective at reflecting sunlight back into space. This would trigger a volcanic winter. Global average temperatures could plummet by 5 to 10 degrees Celsius. A sudden artificial ice age could last years, with freezing temperatures extending into summer even in temperate latitudes. This would lead to widespread crop failure and dwindling food supplies, triggering global famine. The immediate danger would be ashfall. Thick deposits would bury regions. A finer layer would settle across entire continents. This ash is tiny, sharp particles of volcanic glass. When inhaled, it can form a cement-like substance in the lungs, causing fatal respiratory damage. Ash would contaminate water supplies, making rivers and lakes toxic. Its abrasive nature would destroy machinery and clog car and airplane engines, while ash short-circuits transformers, plunging regions into darkness. The cascading effects would be relentless. Transportation halts, stranded cargo, isolated communities, and halted international trade. Economies would collapse, supply chains break, and a global food crisis would trigger mass migrations and humanitarian collapse. The eruption itself may be over in days, but the fight to survive in the dark, cold world it leaves behind would last for a generation. The eruption of a supervolcano would represent a profound threat not just to our civilization, but to countless species, including our own. The immediate blast zone, extending hundreds of miles, would be a zone of total annihilation. Pyroclastic flows move at hundreds of miles per hour, incinerating everything in their path. Entire ecosystems, forests, grasslands, would be wiped from the face of the earth in an instant. For all life in this vast region, the end would be swift and absolute, buried under meters of ash and pumice. Beyond the initial blast, secondary effects would threaten human life across the globe. The volcanic ash, a silent killer, would render huge swaths of agricultural land unusable for years. This would trigger a global food crisis on an unprecedented scale, making starvation the primary threat for billions. Transportation networks would collapse as ash-clogged engines fail and roads become impassable. Sanitation systems would break down, diseases would spread, and makeshift morgues would become grim realities, adding epidemics to famine. Acid rain from sulfur would poison soils and oceans, collapsing marine ecosystems from plankton up. The prolonged darkness and cold of volcanic winter would kill plant life on a massive scale, triggering mass extinctions and shattering biodiversity. Given the apocalyptic potential of a super eruption, the question is not if we should be worried, but what we can do about it. The first and most critical line of defense is knowledge. Seismometers listen for earthquake swarms. GPS measures ground deformation down to the millimeter. Gas sensors analyze changes in chemical composition. This constant monitoring is our best hope for an early warning. A supervolcano does not erupt without notice. The geological processes involved are so immense that signs would likely become apparent weeks, months, even years in advance. This warning period would be our most precious asset. It would provide time to evacuate regions in immediate danger and to prepare the rest of the world for years of hardship. Stockpiling food, securing infrastructure, and developing indoor agriculture are rational preparations for a low-probability, high-impact event. Fostering international cooperation matters because no single nation could handle the aftermath alone. A disaster of this magnitude would require coordinated global response. Investing in scientific research and disaster preparedness is essential insurance for our species. The Earth is dynamic, and we are merely its inhabitants. Supervolcanoes are a humbling reminder. They are not monsters to be feared into inaction, but hazards to be understood and prepared for. The watchers will continue their vigil, listening to the faint whispers from deep within the Earth. It is our collective responsibility to listen and to act on their warnings, ensuring that if the day comes when the ground begins to scream, we are as ready as we can be.